So I'll just give you a little background on the refinery. It's a 2,006 barrel a day on a calendar day basis. Refinery, we produce a high percentage of transportation fuels, and the reason is we have a fluid catalytic cracking unit, a hydrocracker, and cokers. All our products are mainly sent via pipeline to Louisville and then into Indiana and Ohio. And just about everything leaves via pipeline. And I guess, one of the questions I always get is why is the refinery located in Robinson, Illinois? And I can tell you back in 1906 through 1908, it was the world's largest oil producing area. And that's why the refinery's there. So the refinery is 107 years old. So we have a very strong commitment to safety at the Robinson refinery, and everybody has the right and responsibility to go home uninjured. We've been a VPP star facility since May of 1999, and 7 of our embedded contractors have VPP status. We also have an outstanding behavioral-based safety program that is all employee-led, and we are certified by the Cambridge Center for Behavioral Studies. So again, a very, very long record of good and safety and environmental performance. So then we go to our basis for action. And we did experience a toxic gas exposure in 2007, early 2007. And it was while a lone operator, was neutralizing sulfidic caustic and was overcome by hydrogen sulfide gas. And I can tell you, I transferred to the refinery a couple months after this incident, and it had a significant impact on all the employees that work there. And so, one of the things that at the time, the division manager that was there was very forward-thinking. His name was John Swearingen. Today, he's vice president of safety, environmental, health, and security for Marathon Petroleum. But he really wanted to come up with a man-down system after this incident. And so, really wanted to help those that were unable to help themselves. Obviously, in any type of toxic gas exposure or any other exposure, isn't it, time is of the essence of getting help to an individual. And so we embarked on this process to address these points. And one of the things we did is, at the time, the operations manager at the refinery was Kevin Bogart. And he went into a role over the 7-plant or 6-plant system, and where he really led strategic projects. And so he, along with John, we ended up partnering with Accenture to come up with, as a system integrator for this life safety solution. And we worked with them closely to really develop the solution that I'm going to talk about here. So if you look at gas detection history, before we went to the life safety solution, everybody wore a single gas H2S monitor. Again, very common in the refining industry. And then gas bumping and calibration, we required that on a monthly basis. And so, not very frequent. And then that data really, there's no way to reconcile the data to a monitor. And so it was difficult to understand who had that monitor, and then it would really relied on self-reporting of exposure incidents. Now I will tell you, as we implemented the life safety solution, you would expect the number of exposures to go way up. They did go up, but not as significantly as we thought. So I don't think we were under-reporting as much as we thought, which is a good thing. So then, to close the gaps we wanted automatic bump testing and calibration of the monitors. We wanted to understand who is associated with each monitor. We did want, again, 100% reporting. And we wanted real-time data into a central control room operator that could help provide response. And they wanted the location of the personnel to be known. And then obviously a man-down functionality. So if somebody went down with a heart attack, right, it might not be a toxic gas exposure. We wanted to get those individuals help. And then a panic button functionality if somebody was in a difficult situation. Again, those are the gaps we wanted to close. So then we came up with the life safety solution. And I can tell you it's the first plant in the world that this has been implemented in. I don't know of any other facility that has a system like this. And I'll come back to this slide, but the detector, the 4-gas detector with the embedded AeroScout chip that I'll talk about is right here. I have one of these that I can share if you want to come look at it after. There's a Cisco access point on the right-hand side. And then I'll come back to the really the operator interface here, and I'll talk about that a little bit more. So in deploying this is again, I mentioned we're the first to install the life safety solution, and it is across all our process units and tank farm facilities, and it also includes coverage for a remote facility where we obtain our process water near the Wabash River. And so what is it? So, you know, what we did is we installed the Wi-Fi coverage across the refinery. It isn't a mesh network, so some of the APs are powered, just powered, some are powered and connected to a switch. And I will say the important thing to understand here is coverage-based, okay? It is not location, so it's not location-based. And then the other thing that's important too is there's no dead zones in it, right? So really important to understand that. So again, let me go back, just go back and add. I just want to make sure I'm clear on this. It is location-based, so again, it gives location of the individual versus just installing access points throughout a unit that just gives you Wi-Fi coverage. And we also have 10 trucks that have a mobile solution. And then again, we have this 4-gas monitor that combines the industrial scientific monitor, the MX4 monitor, and then it's embedded with an AeroScout Wi-Fi tag. And then this is now rated Class 1, Div 1, so we do have that certified. And the other thing is it's really nice. It gives us obviously the abnormal gas level, panic button activation in front with the red button here, and then there's a motion sensor in there. So, and then everything's transmitted every 5 seconds back over the Cisco network. So we had to define what workers are covered. Right now we cover all the operating employees, and we came up with that just because they're lone worker. They work alone, you know, so they'll be out making an operator around alone. Today we have not as of today we have not covered maintenance, and the reason is they tend to work in pairs, so they don't work alone. And roughly 240 operators are covered with the system at the Robinson Refinery. And what's really nice about it is we can pool these devices. So we didn't have to buy, again, 240 of these. We ended up pooling them, and so there's some economics that we benefited from there. So the work processes are really pretty simple. Is we have a pool of monitors in each operating shelter. At the refinery, there's 7 operating complexes plus the tank farm, so 8. And so we have a pool of monitors in each operator shelter. And so what happens is the night shift comes in. They'll take the day shift monitors that were just released. They'll put them in the docking stations, calibrate, bump test them, put them in the charger, and then the day shift will pick the ones that the night shift had done the same to and charge. So it works really well for us. And but the key thing that I really like here is there was a lot of debate, you know, where should the data go, this real-time data go? And there were some proponents. Again, I want you to make this really clear. This project was driven by the operations department. And so the operating organization at the refinery drove this. So safety didn't drive it, or IT didn't drive this. But we know we did have some input from them. Obviously, we needed support. But you know, one of the things that came up, the safety wanted, well, they'll have our security group monitor these alarms coming in. Well, they have no clue. There's no training. They don't understand what the alarms mean. And so what we ended up doing is at each operator council, we have 7. We have a central control room with 7 operating boards. And each operating board has a monitor where they're monitoring the people in their process unit. And the reason that's so good is those operators, the console operators, are trained in all the outside jobs, so they know all the hazards. They understand when somebody does get exposed, what tasks they were doing, and then also they understand what type of response to come back with. So if I go back in the presentation here, to this screen is up in the upper left-hand corner. That's really that stays steady, it doesn't move, but that's really the alarms that come in there. And so what happens if there's an alarm on H2S, it comes in, it lets the operator know who the individual is that has the monitor, and then it also gives the current reading, so what gas level, so they can see, is the gas level going up, is it going down, or more than one operator exposed, that type of thing. And again, what's nice here is the operators help design this. So the console operators actually help design how this looks. They do have to silence the alarm here, and so they can silence the alarm when it comes in, but they can't. It doesn't automatically roll off like the DCS alarms do. It stays there, and so then they have to make the proper response out in the field, and then after everything's clear, they can clear that alarm on there. What's really nice, though, is the plot areas. They have some ability to move those plots around so they can look at one process unit if there's a lot of maintenance or a lot of activity going on in there, such as a turnaround, or they can expand it and they could look at their entire complex that might have 3 or 4 process units in it. So they give some variability for the operator what they want to look at. And at any time they can click on one of these characters here, who's really the individual in the unit, and they see the real-time data that's coming in on that individual. So again, data is transmitted every 5 seconds. Okay. So the other thing that's really nice about this too is to ensure this 100% reporting. So the alarm comes into the central control room operator, but also what's really nice is then we generate, a system generates an email. The email ends up going to the chief operator who's on shift. It goes to the day foreman who also gets that. And then what happens is the chief operator on shift is responsible then for entering that in our knowledge management system. And that's where we track all our incidents, HAZOP recommendations, so it's just a large database. And then so what happens is I come into work the next day, the next business day, and I automatically know if there's been any exposures. And then what I can do is I can make sure that we get the proper investigation. And so usually what we do, if it's an exposure over 10 ppm and that's our action level, we'll do a Category 1 incident, we'll have the day foreman investigate it, and if it's over 50 ppm, then we'll put a taproot incident investigation team together. So just to give you a feel how we handle those. H2S alarms alarm instantly, so there's no delay in coming in. And so we get those right away. But on the LEL, it is set for 10%, and it does have a 15-second delay. Because what we noticed is there was times when they were disconnecting a sample bomb, it would alarm for 3 seconds, and there were nuisance alarms coming into the console operator. So we put that 15-second delay in there to say, hey, is it really a significant event? And so if the LEL falls back, then there's no alarm generated to the console. And the same goes for the O2 alarms. They're handled the same as the LEL. And then one of the things that we're still working through, I did mention it's a 4-gas monitor. We do have a CO boiler at the refinery. And so we would like the functionality of CO, but right now there's hydrogen interference issues, and it is technically it's an issue that Industrial Scientific is working through. And this is also big for them, I understand, in the steel industry. So they want for blast furnaces and things, they have to resolve this. So, and then for the motion aspects, what we do is lack of motion. We set it 2 minutes, and so if somebody doesn't move for 2 minutes, then it'll alarm, and they have 30 seconds to acknowledge that. So what happens, we had that set much shorter time period. We had it set shorter, and we found that that wasn't a good thing. We were generating a lot of alarms. So we wanted to balance if somebody really went down and when they needed help versus, a lot of nuisance alarms. And we ended up on this 2 minutes, and it's worked very well for us. And so then they have 30 seconds to locally acknowledge it by shaking the monitor. And if they do that, then it clears and it won't go into the central control room. And the comfort stations, and one of the other things we came across is it's wintertime, they put it on their jacket, they go in the comfort station, they hang up their jacket, and the next thing you know, that it's alarming. So we put exciters in at the entry points into the blast buildings, And so when the operators go in their blast buildings or operator shelters, it turns off the motion and then turns it back on when they go out. But all the other readings are still active. And again, then the panic button transmits immediately into the central control room. So an emergency response, and I think again, the key thing I mentioned earlier, all the console operators are qualified in all the jobs outside. They understand the equipment. And so they make radio contact, confirm that the individual's okay, and if necessary, then we'll respond, with the other operators on shift with fresh air or as needed, depending on the alarm. And the key thing is you got that continuous feed of data. So what are some of the intangible benefits? And some of these we just didn't realize going in that they would be there. But, the first one, I guess, is, we realize that, the alarms are reported on detection, so we don't have to reconcile, monitor status reports. I sometimes peruse our other sister refineries just to see what they're doing in the knowledge management system. And what's interesting, I'll come across where they found a week ago, here's 7 monitors that alarmed, or 6, and they're trying to reconcile it, and people are off shift, and they have a difficult time doing that. So we don't have that. And then the other thing is we do store the location of the event and the exposure. So if we do need to go back from an industrial hygiene standpoint, we can. And then again, we have it in our knowledge management system, so we can follow up on these, with engineering controls or behavioral modifications, those type of things. So the other thing that we found that the console operators really like it because they understand where their field operators are at all times. So if they need an adjustment to a fired heater, they need a burner installed, or they need something done, or a pump put online, what they can do is they just watch where the field operator is, and if they're close, they wait till they get over there to that location and then make that request versus running the field operator all around the unit. So that's very nice. It is interesting, though, I find it, is I'll come in the plant on a Saturday or Sunday morning, and I can tell everybody's in the blast trailer. The blast building. That's sort of an interesting thing I've noticed. But I think the other key thing here is when we first implemented this is we were doing a pilot in our Pennex unit, and we had a PSE event where we had a dead leg off a water boot, and it started leaking, and then it hit the hydrocarbon layer, and we had a release. And I remember that there was a couple operators that were wearing the units even when they were in the pilot or beta test phase, and they alarmed 150, 200 feet away, right? So what it told us is, hey, this is a great thing to understand how far a vapor cloud moves. And again, we do have fixed monitors, but in context of that, you will also have 40 or 50 additional points that could tell us how big the release was. The other thing is just behavioral changes by the operators. And I think they understand where their exposure risks are for both H2S and LEL. So a good example is they've made a lot of modifications of, standing, in different directions. We've also added a lot of engineering controls, like closed loop sample systems, where we thought they weren't necessary, but we proved differently with the Ventus LS monitor or the life safety solution. So that's been good. The other one you could argue is it helps us with our LDAR program. And although we have a very good LDAR program, there's a few compressor packing vents that would leak, those type of things that we could correct. So that's been a very positive thing about that. And I think the other thing is, it came up yesterday with the older workforce, the younger workforce. I think what it does do is it helps, I think, our younger workforce understand where those risks are a little better. So I think that's positive too. The other thing I will say too is I was really proud is we shut down a naphtha hydrotreating unit here and reforming unit earlier in the year, or really early last year. And the operators knew about the issues we have when we steam out. And even though we steamed a flare and we put drain piping in and we really tried to keep everything closed and out of the environment, we do have to break some of those connections and do have to steam the low points at the end. And they actually put headers that went up in the air, way up in the air out of the breathing zone. And we had, I think we had one exposure that whole turnaround. So really, really pleased with that. So, we started looking, hey, what else can we use the Wi-Fi infrastructure for? And again, I just, want to make sure you understand is there's a lot of thought, in how the Wi-Fi infrastructure was put in, because we do have 100% coverage, right? And again, for location. And so the really good thing about that is it's just not a coverage thing, but we do have location. And so can you manage contractors, right, at turnaround, or even during routine work or project work, right? So, if they told you, hey, we have 6 contractors, they bill us for 6 contractors, were they really in there working, that type of thing. Asset tracking, I mean, some of these are pretty obvious, you could do that. Then some other things is increased workforce productivity. And really, from the operations side, looking at, tank farm light up so we don't have any quality incidents. Very critical, product quality is very critical in our industry. And so how can we manage that? The other one is just, helping maintenance do work. So if they come down to work on a piece of equipment, they can pull up spec sheets, they can pull up information. The other thing is just remote procedure access. So if I want to go execute a procedure, a lot of times I struggle at turnaround because the master copy is kept in the central control room. I got a field operator with one, but I could have real-time updates if I could sync those two up. Permitting, so you could, have permitting on here. You could have lotto. We talked about other applications such as confined space entry blind tracking, right? So during turnaround that you don't accidentally pull a blind and that type of thing. So I think there's just a lot of applications here that we just thinking of, hey, what can we go do now that we have this infrastructure installed? So thank you very much.